a lot of things to do in some of the problems. I don't think this one's an integration on crack. I think he's a little bit nicer, a little bit, he fits a little bit more perfectly is how we would put it in the notes. But what was messier, yesterday or Friday? Those of you guys that were here for both.
I watched the video yesterday.
Yeah, it was definitely messier. Should have seen period 6, so it was messier. Why was it messier? Basically, very similar problems. What made yesterday messier? I'm not saying it was bad.
We did it.
Yeah.
We started it. We did most of it.
Yeah. I mean, was I kind of guiding in the background? Yeah, a little bit. Was I giving a few hints like du equals u prime dx? Yeah. And you had to make it match a lot. So there was 2 main components. I think one, I tried to have you guys lead the way, and it kept on getting broken up. Because I'm like, okay, just do one step. Okay, just do the next step. And so it's a little hard when it's not just your fluid thought. On Friday, it was my fluid thought, just walking you guys through the problem. But you guys were involved. The smartboard, you guys writing on the smartboard was involved. The thought was kind of broken up from here to there, but at the same time, I think yesterday was way more productive than Friday. Why? Even though it was messier, why would yesterday be more productive? Yeah. Did you guys hear him right? Say it one more time to Kyle. And getting stuck on things you will normally get stuck on. Because Friday, I'd be like, hey, guess what? We can do this. And you're like, what? And I just kept going. But yesterday, it was like, oh, you don't know how to do DU. Let's pause and slow down a bit. Oh, you're not sure how to plug in. Oh, there's an X? What the crud do we do with an X? That's just chilling. Oh, we go back. So it's a lot of just kind of things that happen naturally when you guys are practicing or doing homework or doing problems. Do you ever feel like you get stuck and you're just kind of staring at it like, right? Or you want to be done and you look in the back of the book and you're like, oh, that's not what's there. And Kyle.
CalcChat was no help.
Why?
Because people would use it, but they don't use it.
They are using it, but they're doing it mental math style.
And then the CalcAB video did not have it all either.
Yeah, I watched so many of the videos and these are helping me.
So let me show you just a little bit. That's what you need to work through today, right? Like where to get messy and where do you have gaps in your understanding in what you're able to do. Not what I'm able to do, what you're able to do, right?
Yeah.
Were there any ones with trig last night?
I don't know.
Yeah. Yes. So there were some with trig. Do we at least have the starting of all these problems at least somewhat down? Meaning, can we look at this and say it's not just a basic rule? Because we had this whole approach to integration, right? And the approach to integration, some of you took a picture of it yesterday, some of you watched the video from Friday, some of you were here for Friday. Oh my goodness. Step number 1 is apply a direct rule. Is this one of those memorized antiderivative rules? No. Can I like, distribute the square root and split it up and make it look like a basic rule? Exactly. I just killed so much stuff, so you should be like horrified back there. Keep the horrified face, and we say no. Kyle has a horrified face. So what's my only other option, to be honest?
You it, baby.
U it up? Sure. So we're just thinking about who's the innermost and who's the innermost. 2 plus cosine x. Don't say the square root. We can deal with that as a negative 1/2 power. The innermost. What's underneath that square root? There we go. Du is equal to u prime, which is 0 minus sine of x times. Okay. Now what do we always do with du? Get dx alone, because where are we plugging this all into? Exactly. So we're trying to plug in for dx because we're always going to have him. Remember, that doesn't always match perfectly or nicely. Okay, we just need to be careful. So we're getting in that du over sine of x, and yes, there's a negative. Can I just put it in there? And then usually, usually, wherever we got the u from, we can just go throw it in. I mean, we can always do that, just usually it's helpful. So then when I go to rewrite this, if I was keeping it the indefinite way, like the x-bound way, and saying like, hey, x is within negative pi over 3 to 2 pi over 3, I could kind of like have this off to the side and just treat it like an indefinite integral and come back to the bounds in a second. That's one way. Those are called basically just keeping the x bounds. And I would plug in and get my indefinite integral sine of x over the square root of u times negative du all over sine of x. What happens to those sine of x's? You guys had yours cancel out too? Question, did you pull anything out because you can? Mm-hmm. Did you rewrite anything because you can? You did that? How are we doing?
Good.
It's a little bit nicer than yesterday, even though there's trig, because it fit perfectly. Okay, it was off by a negative, but we just pulled the constants out. Now we have a basic rule, yeah? So now we can go ahead and say, okay, that's going to be, fine, a negative. And then u to the, what happens when I add 2 over 2? I'm adding 1. 1/2. What happens when I divide by 1/2? Multiply, if you want to just think of it as a reciprocal, that's fine too. Multiply by 2 over 1 or 2. Don't forget your. Now, if we did this the x-bound way, what do we have just kind of chilling and waiting for us to get back to it?
The x-bound.
So if we have x-bounds, we can't stay in terms of u. We need to get back in terms of x. So at this point, we would go ahead and say, okay, so what do we have? We have this original expression equaling negative 2, the square root of who? Evaluated from, now I can bring my negative pi over 3 and 2 pi over 3 back. And because I wrote this statement at the beginning, all these equals are still valid because I'm talking about the definite integral of, and I'm solving, and now it's time to go ahead and get back in terms of x. So to finish off the problem, now if this was a long answer, like an FRQ, like an essay part A, yeah.
And subtract within 3.
And the really cool thing is actually, and to be honest, I just learned this because, I don't know why, I think I've heard it before, but I didn't fully believe them, I should have. You don't even have to do the unit circle if it's a long answer. You just get to leave it like that. It's what they call a numerical expression, and it's okay. Which is a good thing, because some of your unit circle is not so strong. Not to say it shouldn't be strong, oh my goodness, it's a forever card, but to be better safe than sorry. To be better safe than sorry. So it was a long answer. We would box it and be done. Yeah? Just the unit circles. Just the unit circles. This is a long answer. You box it and be done. But if it's a make it match, because typically just a good old-fashioned definite integral is, especially if it is a unit circle expression, then we would go ahead and have to finish this off with, well, it's a little bit nasty because cosine of 2 pi over 3 ends up being square, no, 1, 2, 3, 3, 2, 1. Oh, it's just 1/2. It's a negative 1/2. It's in the second quadrant. And I have minus a negative, which will be plus 2 times negative pi over 3 is still 1/2, but a positive this time. So it'd be a little bit gross. I guess we could pull out that common 2 in front. We'd end up with 4 over 2 minus 1 over 2, which would be the negative square root of 3 over 2. And then we'd have plus the square root of 5 over 2. Which means technically we could multiply by the square root of 2 to rationalize, just because I see a lot of 2's and I'm guessing they're going to want to simplify. Or you could be snazzy and be like, isn't that 2 to the 1 over 2 to the 1/2? So maybe it's a little easier. Just think exponent properties. 1 minus a half ends up being a half. So we end up with the square root of 2 all times square root of 5 minus square root of 3 all over 2. In which case we could distribute that because they're all in the radicals, and we could get root 10 minus root 6. Not pretty, not nice. I know. Could you get it right? That's the first question, right? And then, okay, maybe it match. It's a little bit more exciting. Now, how could you have also done this? The alternate form would have been, instead of keeping in terms of x, which is what we did here, I think yesterday, technically, did I make that green or did I make that blue? What was keeping in terms of X? Oh, X was green. It was kind of the old-fashioned way of not doing anything new. Let me erase this and make it green. So keeping X bounds, we kind of got back in terms of X and we plugged in those X bounds. The other way that we could have done it is that we could have actually up here, we could have looked and seen what is u of 2 pi over 3, the top bound, and what is u of negative pi over 3, the bottom bound. And when we plug in, we would have said, what is 2 plus cosine of 2 pi over 3? Well, cosine of 2 pi over 3 is a negative 1/2. 2 minus 1/2 is 3/2. Got it. And then we could have done the same thing and gotten 2 plus 1/2, which is 5/2. Got it. And then we could have actually, right here, instead of having this expression, we could have actually plugged in 5/2 and 3/2, putting the upper bound equivalent in the upper bound spot, regardless of who's higher or lower, and the lower bound equivalent in the lower bound spot. And then we could have just carried those u bounds, 5/2 to 3/2, those u bounds, 5/2 to 3/2. And what we would have gotten was a -2, okay, cool, times 3/2 square rooted minus 5/2 square rooted. Now, would we still have had some simplifying to get it down? Yeah, but wouldn't it have been the same thing? Plug in the negative, that's a -√3 over, and a positive √5. It is the exact same thing. So u bounds just say, I'm going to do this plugging in over here, and then you just use the bounds and never go back to x, because I'm staying in u's the whole time. Once I make this transition of the bounds also, x bounds say, let's just go to u's to find the antiderivative, then let's get back to x's, then let's plug in. So one's kind of procrastinating till later, the plugging in, and the other one says, now, tackle it now. There's a life lesson in there somewhere. But there's also a natural tendency in the sense of which one will feel a little bit better to each of you. Okay, I want to know one of those ones where you guys tried to watch a video, because I know some of these are pink, right? You tried to watch a video, Kathleen, you were the one that brought it up, but maybe others have an opinion too. Where's one you tried to watch a video and you were like, it's not helpful? Or Kyle, you brought it up too. Give me one. Where's one where you tried to watch a video? Color pens out, homework questions at the ready. Some of you guys might have this homework totally ready to go. Some of you might not. Here's the first page of notes that we need to get through today. Section 4.6. We're not going to totally finish it, but we do need to at least get some examples down so you can take a picture of it and be playing with it if maybe we're covering a question you don't need. It's not going to be on the screen for super long. You can grab a picture of it. I'm going to pause and freeze the screen so you guys can get this down, or you can at least get a picture of it. Kyle, did you come up with one, or Kathleen, you come up with one? The pink ones are like 1 or 11, 27, 37. Okay. 37's a really rough one. It's a double angle. In that whole section, the 31 to blah. Kyle, did you have one from earlier that you were like, 11? Okay. So we'll start with 11 because he's a little more basic, kind of like how you were saying, Kathleen, like it got harder in the 30s. And then let's make our way over to the 30s. And I will try to show you what CalcChat or how CalcChat is showing their work. I don't disagree with it, and if you were in CalcBC, I actually fully support it. But in CalcAB, I feel like the way that CalcChat does it is expecting a higher level of mastery from you guys, and not just the easy but the hard problems. And so that's why I have a different system. I'll put it that way. Similar process. Just a different way of getting there. All right, hopefully you guys at least have a picture of this. We will be back to it. Some of you are seeing like, oh, there are more rules coming. However, hold on. Okay, we do have section 4.5, the evens up and ready to go. But I think, oh, I did give you a few evens, huh? Yeah, I did give you a few evens. But with those evens, I'm hearing from you guys that you're like, but wait, like number 11 was an odd. It was an odd with a video, and we still got stuck because they're showing things differently. So I'm going to go ahead, and I don't know if you guys will be able to see this. I can try to zoom in as much as possible. Ish. I'm going to throw him over here, though. So you guys can be looking at, can you see the final answer, 14? Not quite. You can see the work at least for number 14. Let me see if I can zoom out just a little bit. Because I'm going to put the book up on the other side and go find that number 11. Okay, there we go. You can kind of see the first side. And so for number 11, let's go see what's going on. Let me make it big and just get a picture to put off to the side. Okay, number 11 for us is a fairly typical U sub in the sense of, oh, come on. This is not going to be a fitting exactly from the beginning of our examples. But it's also not going to be an integration on steroids either. This one is actually going to be one of those that's just off by a constant. The reason I know that, well, let me get into it. Let me get into it, and then we can look and see. Here we go. Okay. Hopefully U is a pretty easy pick. In the sense that you're looking for the innermost, and the innermost would end up being that 2x cubed minus 1. Hopefully you have your system at least somewhat down to where you're like, I always know to go looking for du equals u prime dx. And then we take that dx. What I think simplifies the harder problems for CalcAB kids with u sub is solving for this dx. But this is the step that CalcChat does not do. Okay? What CalcChat would instead do would say, I want to get this, yes, U plugged in. I have a nice easy spot for that. But I also want to get this du plugged in. But what they're going to look at is what's over here equal to du. And instead of like going apart or away from the du and saying, okay, whatever, I don't care. Like I have a dx, let's solve for the dx. What CalcChat says is, you know what I want? What I really, really, really want is 6x squared dx. If I could get 6x squared dx in my integral, I can just take all of that out and I can put in du. But I don't have a 6. Well, in math, how do we put in a number that we don't have currently? We multiply by 1 creatively. And so I can get a 6 in here if I multiply a 1/6 out here. Technically what you're really doing is you're really multiplying the inside by 6 over 6 and saying, I need you to stay and I want you to go. So you're actually pulling out the 1/6, keeping in the other 6. And the reason you're doing that is because now all of a sudden, in one fell swoop, they're like, look, it matches. And if it matches, then we can go ahead and take that du and say, haha, you take the place of all of this. And so then they go straight to, with that little creative 1/6 that they brought in to make it 6x squared dx, now they have all of a sudden just a u to the 4th from my u taking the place of 2x cubed minus 1. And then all of this gets outright substituted for a du. What they're trying to do is not have an expression with x's and u's at the same time. My way of doing it, or at least the way that I show you guys, technically I kind of do it mental math style, like the BC kids, but that's after a lot of experience. How I have you guys do it is say, you know what, there's always a dx. You don't have to go like making it match, just get the dx and then we'll deal with whatever problem is left. And so when you guys would go to plug in, you would have had your x squared u to the 4th times du over 6x squared. It's awkward because, yes, you can't solve this integral. It's technically in some ways illegal because there are x's and u's. But with one quick little one quick little reduction, and then, be careful, it's a 1 over 6, blip, pull it out, you end at the exact same place they do. You end at the exact same place. They're just going the creative route of saying, this is what I want. Okay, I'll make it work. And you're going the, I don't know, I have a dx. Let's just plug that in and see what's left. And for integration on crack steroids, whatever you want to talk about it, the crazy one where it's like you have to rework not rework, but come back in and do some crazy extra substitution this way is a lot simpler in thinking about it. Now, Kathleen, when you were asking Kyle, that's good? Is that good? Sorry. Kathleen, you were saying number 37 was to help you for 33? Number 37, I didn't give you guys because 37 is a bit of an interesting problem in that it has a sine cosine. And the only place or the main place you have ever seen a sine times a cosine is in the double angle of sine formula. Ooh, that's one that we wrote in our forever cards at the beginning of the year. The double angle of sine formula. So when you were watching that video, the bad thing is that this was a tricky pre-cal property in that back in the day, sine of 2u is equal to 2 sine u cosine u. I can integrate this a lot easier than I can integrate that. I don't have a product rule for this. That's a little rough. So one way they could have gone is actually rewriting this whole thing to be the integral of sine 4u. Sorry, 4x. My bad. Because sine of 2 times whatever something is in here, it's sine of 2x, cosine of 2x. We could plug the 2x, and 2 times 2 is 4x. The problem is there isn't a 2, so they could go to a 1/2. But there again, that's pretty out there. You could have then done a u sub and said u is equal to 4x and du is equal to. That's one way. That would have been a pretty advanced way, and yet a very valid way. The other way, though, that you could have done would have been. The other way that you could have done is actually choosing each one, well, one of them to be u. Because if you choose sine to be u, his du has a cosine. If you choose cosine to be u, his du has a sine. I think I'm going to go with sine just because his du is positive. Now remember, our way says, whatever, we have a dx. We don't even look at what's there. Let's just get dx by itself, and then we'll reevaluate. Then we'll come back and see what's really going on. So cosine 2x times 2. So we would take that and we would plug in saying, at least I have a spot for it. CalcChat, though, on the other hand, is going to be like, no, I want to plug this straight in. And to plug this straight in, I need this to be there. Yay, I have that. That's good, but I don't have 2. So then they're going to multiply everything by 2 over 2. They're going to bring the 2 in, and they're going to keep out a 1/2. And if they bring the 2 in, then they have a place for their u to go. And then they have, nope, not 1/2, sorry. The 1/2's on the outside, the 2 is on the inside. And they're like, haha, I made it match. So then they're going to say, yay, go straight in. But either way, whether you use our trick of plugging in du, which would lead you to the integral of sine, I guess we can plug in. That would be our u times cosine 2x times du over 2 cosine 2x. We're going to end up with, remember, it's not a 2, that's a 1/2. 1/2 integral of u du. And they're going to end up with 1/2 integral of u du. So the bummer of it all is that those of you guys that got stuck on how CalcChat was showing work, you weren't confident in the method that I showed you. Because if you were, you would have seen the integrals matching up in a step. Did you see it though? Like you got stuck in like, wait, they're not starting like me. Well, they did start like you. They just kind of went a different direction. They said, no, I want to manipulate it myself and make it match. Whereas we say like, I don't know, it might not work out nice. We're just going to solve for dx and put it in and see what happens. This is a bit more formulaic and this is a bit more creative. If you're a T-proof person, this would be like a manipulating, transforming, making what you want it to be. If you like completing the square, this way is great. If you don't like completing the square, being creative, you're like, I'm just going to solve for dx and plug it in. That's fine. Does that kind of give you what CalcChat's doing? The idea? Are they jumping steps? Of course they are. It's CalcChat. But they just have a different approach of wanting to make it nice and pretty and ready to plug in first, and we're saying it. We don't need it to be nice and pretty. We just need the x's to eventually go away. So then coming back, you guys have already maybe been able to grade 2 and 4 and 14. There is like a simplified form of 14. If you multiply 1/8 by 3/2, you get 1/12. And then number 30, you guys were able to see it was over there on the side screen. The checking is just taking a derivative and making sure that you're good. But here's 62 and 66. You guys are checking that, Kathleen. I know that you mentioned 33. It had a trig, which might have made it look nastier. But to be honest, cosine of is actually pretty straightforward as long as you weren't worried of the trig. Now, hold on. This is our way of like, whatever, let's get into the dx. Remember, they would have said, no, I want an 8. So they would multiply by 8 over 8, bring the 8 in, have a 1/8 out. But our way says, whatever, put in a du over 8. Cosine of u. Ew, he's a constant. Get the 1/8 out. And we end at the exact same place they do. Kathleen just asked about number 33, so I was just showing them. What has a derivative? Oh, 8x is going to go back in, true, but anti-derived first. So then how or who gets a derivative of cosine is sine? Wait, is that a positive or a negative? Positive, good, because derivative of sine is a positive cosine. Good, and I have my 1/8, but then we also need the 8x when we put our u in eventually. Plus. Is that good? But remember, CalcChat would have totally done that. No, I want it to be gorgeous and perfect, just ready. So then I need to go ahead and do an 8 over 8. And then it's like, ooh, du, come on in. Whereas we're like, no. We have a dx, let's just, and then we figure out what's there and deal with it. 2 different approaches. I've taught it 2 different ways. I used to always do it the creative, this, like, see it, get the du in, and if it's not able to go in yet, make it match. But then I realized other teachers are teaching it this way, and I'm like, man, that's so much simpler in the brain. As you're still mastering. Whoa, number 62, there's no plus C. Oh, yeah, there was. Wait a minute, how did he go away?
Because it was one of those plug-ins.
There was a clue. You had to plug in your X and plug in your Y and know how to do the 3/2 power. Oh, some of you guys, do you know how to do the 3/2 power? 3/2 power? Just because some of you were like, I can't solve for it. Remember, 3/2 is the same thing as 1 1/2, which is the same thing as 4 times the square root of 4, which is the same thing as 8.
Whoa, can I just do like 4, and just do the square root of 4, and then
You can, but depending on the problem, it might be nasty to cube something.
Well, didn't you say you can square root first and then cube it?
Ooh, I was saying order of operations. We can actually do this. So the square root of 4 is 2, and then cube is 8. Nice. That works too.
You taught me that.
Otherwise, you have to do 64 square root of which is 8. That's fine, but if it was a bigger number, like 13.
Or if it was 4 to like the 5th power.
Well, 13 square root, you can't really do much. If it was something like 49 to the 3rd power, but the square root is 7, and 7 to the 3rd power, at least it's small enough. Anyway, we have a couple more evens, don't we, someone?
Yes. We have to do one more.
Ooh, it was an integration on steroids.
Everyone knows steroids.
Now, pause. This is, coming back. Let's just shake our head and move on. Remember, there's going to be answers like this with the x's plugged in, and it's going to be wrong. They're going to tweak like a positive, and they're going to make you second guess all your life choices and be like, I bet I made a mistake because that looks like it. And you're wrong because you should have simplified it. It does end up looking a lot nicer than you think. Green, pen, trick, 118. There's that trig. Looks a lot like what we just did, except would you guys have chosen this to be your u? Because the derivative of tangent is secant squared. The du works quite nicely. Oh, CalcChat, what are you doing? Why did you put a random 1/2? Oh, because you wanted the 2, because you wanted it to be perfect and nice and neat before you kept going. It is what it is. Where they're used. They used it. They just kind of made it look pretty and then thought, oh, it's u cubed du. That's 1 point u to the 4th. They're skipping steps. They're skipping steps. Anyway, final answer is A, and then we're done. I realize we have more questions, very possibly, on section 4.5, but we've been able to grade the evens. We've been able to go over some of your questions. Can you guys just leave your colored pen, your red pen, your grading pen, whatever it is, I grade in blue, whatever it might be. Can you just close your homework spirals for a second? Can we go do just a little bit of this LN stuff, and then if we have an extra few minutes, just have one ready for me to go over? Yes, I did that earlier. I'm officially caught up in my endeavors. They are completely caught up in my forever done. Not quite. Anyway, but I think the online forevers are up to date. Oh, thank you. No. I don't know. I think this is the last one. Cosecant, cotangent, yeah, 5 is the last one. 5 is the last one. Let me zoom out just a little bit more. Boop. There we go. I think I like that better. Yeah.
What was I had my favorite card. No. 39.
All of them? Or is it just, oh, because you're caught up. That's right, because you guys had your cards all caught up for the last week. This is forever number 20.
Yeah.
9?
29. Yep.
30?
30.
39. Oh, I was in the 20s, sorry. Forever number, BC is in the 20s. Forever number, or you can think they're in the 70s. How you want to think about it. But, forever number 39. Double, triple check, that's right, yeah. When does the power rule, we've already written it down in the card, when does the power rule not work? X to the n dx equals x to the n plus 1 all over n plus 1 when n does not equal negative 1. Right? If you have 1 over x or 1 over u, the power rule does not work. Why? Well, negative 1 plus 1. What's negative 1 plus 1 in that denominator? What would be chilling down there? A 0. Can I divide by a 0? No. So we are so lucky that the power rule literally fails and gives us a D and E answer, because otherwise a lot of you would keep on doing the power rule, even though we have this little like ding, 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 doesn't work. Lucky for us, it doesn't work. Literally, you would be dividing by 0, which should be like warning bells, looking down and saying, oh, that's right, 1 over x is ln. 1 over x is ln. Even though 1 over x is ln, maybe just a few of you want to think about this as not just a 1 over x, but what if you were to have a 1 over u with the du? Then it would just be ln of u, if you can get the du. 1 over u du would be ln of absolute value of u. There is no u prime. There is no finding u prime when you anti-derive. I mean, there is finding a du and getting the integral to be pretty. But 1 over t dt is ln of t. 1 over u du is ln of u. 1 over y dy is ln of y. Absolute value, technically. That's you. And if any of you guys are curious why the absolute value, what is the domain of 1 over x? Basic graph. All real numbers, but it's vertical asymptote at 0. What's the domain of just an ln? Natural. All positives. Well, wait a minute. If he's allowed to have anybody, but his antiderivative only has half of those people, that doesn't match up so well. Exactly. So because he has a domain of positives and negatives, I need the ln to work with positives and negatives too. And it's the absolute value. Because we're not starting with the ln, we're starting with the 1 over x. Anyway, guys, we have these rules. So now that we have these rules, anytime we learn new rules, what do we then do?
Use
Use them. Now, the nice thing is, you guys have already seen just a couple LNs. I think I gave you 1 or 2 when we did our basic rules. And so this is actually a repeat, yeah? So if he's a repeat, that might be another reason to make it 1 over u du is equal to ln of u, just to kind of change it up and be like, oh, that's a thing. But tangent, cotangent, cosecant, they all have ln's, and we haven't seen those before. But let's start with some basic ones. Basic, yeah. Basic, because does that 10 fit in any of these rules? Oh, I can't use, wait. Isn't 10 just like a constant?
Yeah.
Can't I think about this as technically 10 times 1 over x?
Yeah.
So what can I do to any constant coefficient? Pull it out. Oh. Oh, what's the integral of 1 over x again? Dun, 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 dun. Well, actually, you could also make it ln of x to the 10. Dun, dun. Oh, because logarithmic properties. I can take the coefficient and make it into a power, and then where did the absolute values go? It's, yeah.
Even.
I mean, got it. The 10 is even. If the 10 is even, whatever you put in there is going to end up being a positive. Whatever you put in there is going to end up being a positive. There's no need to say you need to say positive. They all will be. Okay.
A negative positive.
Wait a minute. This one has an x to the 3. This isn't an ln.
Or is it?
Or is it? Don't you kind of have a 3 minus x cubed stuck down there?
Yes.
And whenever you have something stuck inside, what do you need to be thinking? You. Bigger picture.
You.
You. No, that's E.
But you.
You. Du. What do we got? Good. Negative 3x. Our way is to get dx alone because dx is right there waiting to be plugged in for. Their way is that I need it to be perfect. So they would have multiplied by a negative 3 inside and a negative 1/3 outside and gone straight to du. Our way says, whatever. Dx is equal to du over negative 3x squared. I have a place to put them because I always have a dx. And then we got that u from somewhere. So then we end up plugging in, and with one quick simplification, being to the same place that they would be with their little creative negative 1/3, negative 3 stuff. X squared all over u, just to the power of 1, right? There's no extra squared or cubed or half power with a square root. And then I get my du over negative 3x squared. Those x squareds reduce.
And if you get up to 1.
Not a negative 3, it's a negative 1/3. Which leads me to a negative 1/3 integral of 1 over u du. Oh my goodness, 1 over u du. Isn't that ln? Ln of u? Who is u? Can we make this jump or is it too much? Who is u?
U is 3 minus x cubed.
Let's see. Is there another way of writing it? Yeah, it's just not very pretty. It would be ln of this guy raised to the negative 1/3 power. Negative says down in the denominator. 1/3 says a cubed root, and it just got kind of worse. And 3 minus x cubed, the bummer is it's a cubed root, which means it could still maintain its positive or negative, so I still need the absolute value.
Let's see.
I'm thinking that they would do this one, but I'm just letting you know. I mean, it could show up the other one too. But yeah, let's see. Sorry, he's kind of squished.
Ooh. We're getting difficult now.
Wait a minute, difficult. It's just secant, no big deal. Secant tangent is the derivative. I'm not taking derivatives.
Taking
Anti-derivatives. What's the antiderivative of secant? Well, secant squared goes to tangent. Secant tangent goes to secant, and there are no other secants anywhere.
We just learned them.
Oh, but there's a box. There's forever number 39. And forever number 39 says, ooh, you only thought there wasn't something for secant. It's a little bit complicated, and yet it's still a thing. Now, careful. It's not just secant of x. It's secant of a u.
U.
I'm going to make it 1/2 x because that makes my du a little bit easier to think about. You could have done a quotient rule, bottom to top minus top to bottom, all over bottom squared. Or, 1/2 x has a derivative of 1/2. dx is equal to 2 du. Or the AP guys would be like, or I should say the CalcCAB guys, I need it to be perfect, so I'll put in a 1/2 on the inside and a 2 on the outside either way. We end up plugging in and getting secant of u with du times 2, and I pulled a 2 out, and we have to go to our rule and say, ugh, this is messy, we better memorize it. 2 times ln of, I know it, but do you? Nope. Read it.
Plus n.
But in this case, it'd be secant u plus tangent u plus c, right? And who is the u?
I'm U.
Ah,
U
who is this u?
Yes.
X over 2. Could we go ahead and make all of this with a squared and take away the absolute value? Sure, but I just ran out of room, so we're not going to. Wait a minute, who's that next example? What? I don't
What
either.
are you doing to us?
I decided, just looking at the clock, I'm not going to go back to section 4.5 today, and then instead do it tomorrow, because 4.6 isn't due until Thursday. And some of you got thrown for a loop when CalcCAB wasn't doing it my way.
Yes.
So I might give you a little chance to go back and revisit that homework this afternoon, this evening. I might extend the Google Classroom deadline to be midnight tonight instead of 8 a.m. this morning. Only for, like, if you did your best and, like, I can tell it was fully attempted, that's fine. But if you got stuck and kind of like, I don't even, it doesn't look the same, I'll let you guys have till midnight. Sound good?
You are awesome, Miss Steve. You know that.
Grace has been given. Grace should be extended length. And like an authority figure. But wait, number 4, it doesn't look like a 1 over. Can't I just, but what do I?
Quotient.
I know, right? But we don't have a quotient rule for integration. Here's something that we haven't talked about because we haven't really needed to yet. But it's going to be very, very helpful for you guys going forward. Whenever you see an improper fraction. Improper fraction, yeah, it used to be a thing when we were looking for fancy asymptotes way back in the day. Or when we were trying to split something up in partial fractions.
Stop it.
Don't worry, this isn't a partial fraction one. Now, if that was like x minus 2, x plus 3, it would be BC. Anyway, coming back. Improper fractions, whenever we were trying to do partial fractions, we always had to say it's top-heavy. If it's top-heavy, we divide? Why would we divide it? This makes no sense. I would just rather split up, but it's not pretty. Why am I? Yes, you could if you want. Why would I, but not always if it's not like an x plus or minus term? Why would I even be doing this? Did that just make it a lot better if that was what was in this, the integral?
Yeah.
What's the integral of 2x? X squared. What's the integral of 11? 11x. What's the integral of 19 over u? Ellen! Alright, you guys can get out of here, but I'm going to finish it up in the video. All the math stuff is colliding. Those things that we learned are actually useful.
It's the Big Bang.
The big, okay, maybe not that. A little dramatic. Bye, guys. Have fun thinking about integrals all day. Just kidding, I mean maybe.
Add abbreviation? Yes, you are. Renegade.
There you go, Adam.